Hey, welcome to this video on solving logarithmic equations with lots of smiley faces and lots of smiley faces for different reasons. One, um, one is I love exponentials and logs, and it's probably my favorite unit in Algebra 2, and then we never get to it till the very end of the year. And for the year that I am recording this, which is the 21-22 school year, so if it's not that school year and you're watching this video anyway as a resource, sorry. But for this school year, it is probably the last lesson that I'm going to record for the entire year for any of my classes. So the end is in sight. Okay, so enough of that. Let's do something. Let's solve some stuff with logs. So in class, this goes with a handout that's like fill in the blank, and we're going to work through it together in class. I developed this handout actually last school year to go with some videos that I had recorded, I think, during testing. It was when my students were doing this. But anyway, we're going to look at it. We're just going to go through it as a video for those of you that might not be in class and you need to make up the notes, especially for this year. There is an open notes test online. And so you definitely want an opportunity to get those notes. So for this first little introductory blurb, it says, if there are only two logs with the same base, and honestly, in all of the problems I've done in logs as a math teacher and as an engineer, and also taking a lot of science classes, I've never seen the bases not match in a problem. That's not to say that there aren't some cases where they might not match, but it's not something you need to lose sleep over, like what if they don't match. So logs with the same base and no other terms. So we need to make sure we know what that means. Isolate one log on each side of the equal sign. You could even say each side of the equation, and set the arguments equal. So that is arguments. So there's a lot of vocabulary in here, and for those of you that are watching this, you've been in my class all year, you know that I'm huge on vocabulary, because if you don't understand what the words mean, then you can't interpret the directions. So when we talk about logs with the same base, let's remember that that means you have like log, and then that number right there is the base. And so we would have like log base 3 and then another log base 3. You can't have a situation where you have log base 3 and then a log base 2. Okay, it won't work. And no other terms. So terms are things that are added and subtracted. So if you have log base 4 of 5 and then you subtract 3, now you have another term. Okay, so we're dealing with situations where we have two logarithms that have the same base and no other terms. So that means that we can't have anything that's like added, subtracted. We can't have like other things. Then what we do is we isolate one log on each side of the equal sign. So it's going to look like this. You're going to have a log on one side and then a log on the other side, and set the arguments equal. Well, the argument is whatever you're taking the log of. So in that case, that example right there, the argument is 5. And so if you have log A equals log B, when we talk about setting the arguments equal, I'm talking with my hands here, setting the arguments equal, what we mean is that A is equal to B. So we want to avoid saying things like the logs cancel out. Yes, kind of, but the mechanism by which the logs are canceling out is because they are no longer relevant, because we're going to undo them and arguments end up equal. What I have seen students do, well, you know what, let's go over to the example problems and I'll kind of model what I've seen students do that indicate a misconception of the algebra and what's happening in the problem. So for the first one, okay, this illustrates very clearly what we're saying in that little introductory blurb. We have two logs. So if there are two logs with the same base, okay, so base 3, and no other terms. So we don't have like a 3 out here, 3 plus log, or log of base 3 of x minus 4 minus 7x or anything like that. So it's just two logs. what we can do is isolate one log on each side, and in this case, it's already done. So we have one log on the left and one log on the right, and now we're going to set the arguments equal. So the arguments, in this case, the argument of the first one is 2x minus 1. The argument of the second one is x plus 4. And what we're going to do is set those arguments equal. So 2x minus 1 equals x plus 4. And you can do it just like that. And if somebody were to ask you, well, what did you do? Or where did the logs go? You would just say, well, the logs were equal, so I was able to set the arguments equal. What you don't want to do, so if you are taking notes and you're writing stuff in your packet, which I hope that you are, don't write this down because this is wrong. Don't do this, okay? That's supposed to be a 3. That is not what is happening. No. That is division, and division undoes multiplication, except that's not multiplication. So you can't undo it with division. You can undo it by exponentializing. You can do some stuff with some exponents to undo it, but you definitely can't undo it by division. And log base 3 with no argument doesn't mean anything. The log has to have the argument with it. To have, like, say something like log base 3 with no argument, and you're just gonna, it's like having a square root with nothing under it. It doesn't make any sense. And nobody does a problem like this where they divide by like a square root with nothing under it. Okay, so you just can't do it that way. You cannot have a logarithm with no argument in the same way that you can't have a square root with no argument underneath it. So in this step, this first step that we're talking about, the reasoning is that if the logarithms are the same, then the arguments must also be the same, and you can just set the arguments equal. So don't show any other kind of work in there, just set them equal. And then you can solve whatever kind of equation that is. In this case, it's a linear equation. So we'll subtract x from both sides. 2x minus x is 1x. And then add the 1 to both sides, and x is equal to 5. Now, with log equations, one of the steps you have to take is you do have to check your answers. So if you recall back when we were doing domain, I said the big restrictions on domain are fractions and square roots. I said that's going to cover you about 85–90% of the time, but there are some other functions that have restrictions on domains. Logarithms is one of them. So you can't take the log of anything other than a positive number. So when you take your answer, you do have to plug it back in and make sure that you do get a positive number. So you can often do that in your head. 2 times 5 is 10, minus 1 is positive. And honestly, it doesn't matter what it is as long as you're checking to make sure it's positive. 5 plus 4 is positive. Okay, so you don't have to do it out. I mean, hopefully you know that 5 plus 4 is 9, but it's not something that you have to do out. You can just check to make sure it's positive. All right, so with this one, we have the same situation here. We have 2 logs. They are the same base. They are base 4, and there's nothing other than the logs going in there. So we have log base 4 of x squared and log base 4 of 2x plus 15. And there's nothing else there. So there's no other things being added or subtracted. So if that's the case, then isolate one log on each side of the equal sign. So here we have equal to 0. This is conveniently a minus sign. So the way we're going to isolate it is we are going to add log base 4 of 2x plus 15 to both sides of the equal sign. Okay, and I know my handwriting got a little messy there, so hopefully you're listening and not just watching. Log base 4 of 2x plus 15, and then we're going to add it to both sides. So if you've got negative log base 4 2x plus 15, and then you add it, these cancel out, giving you 0. And so you are left with log base 4 of x squared. And then on the other side, we have 0 plus log base 4 of 2x plus 15, and that's how that first step looks. Once you have it with one log on each side isolated, then you can set the arguments equal. So x squared equals 2x plus 15, and then you can proceed to solve whatever equation is left. In this case, this is quadratic. You notice quadratic because of the x squared. So when I do this in class, I'm going to stop and ask that question, and hopefully someone in the class will say, that is a quadratic. And I know because it's x squared. And there are two strategies for solving a quadratic. You can factor it, or you can use the quadratic formula. We could also complete the square or try graphing it. There are some other ways. So now that you know how to use Desmos to solve anything, you can graph the left, graph the right, see where they intersect, take the x coordinate. That is totally fair game to do, but I'm in the middle of a PowerPoint, so I'm not going to do that. So in order to factor, you have to get a 0 on one side. In order to do that, I am going to take the 2x and the 15, and I am going to subtract them from both sides, getting x squared minus 2x minus 15, and then I have a 0 on the right. Now I can factor it. And we are looking for two numbers that multiply to negative 15 and add up to negative 2. This doesn't ever go away. So if you are planning to take college algebra, if you are planning to take pre-calculus, you can't forget how to factor. You can't forget how to recognize a quadratic and what strategies you have at your disposal for solving it. Like, this is one of those long-term, long skill, like algebra skills. As long as you are stuck in an algebra class somewhere, you're gonna have to do this. So these numbers would be -5 and +3. Okay, you do a quick little check. -5 times positive 3 is -15. -5 plus 3 is -2, leading me, and then we would employ the zero product property. So if you have two things that are multiplied together and the product is 0, then one of the factors has to be 0. And adding 5 to both sides gives us x equals 5. Subtracting 3 from both sides gives us x equals -3. Now remember what I said about having to check to make sure that these answers, like these problems, don't give you negatives, okay, in your square roots. So looking at the first one, if I take a 5 and I plug it in here, 5 squared is positive, okay? You don't even have to answer what 5 squared is. It's a positive number. If you square a positive number, you're going to get a positive number. Over here, 2 times 5 is positive, and a positive plus 15 is still going to be positive. So the 5 checks. -3, if you take -3 and you square it, you will get positive 9. 2 times -3. Now here you actually have to do a little bit of work. 2 times -3 is -6. -6 plus 15 is positive. I don't need to know exactly what it is, but -6 is going to be outweighed by the positive 15. So in this case, both of the answers actually check. That is not always the case, and so you do need to be pretty vigilant about checking. So pause the video here if you need to, and then when you're ready, click on over to the next slide. So this next one is a you try one. And what I expect you to do as you're watching the video is to do what we would do in class, which is, I would stop, I put some time on the timer and give you a chance to work this problem out. And then once you've had a chance to work it out, then unpause it. I am going to work the problem out on the left, and you on your handout in this space over here on the right, you are going to make corrections or notes. So if your problem is wrong, you're going to copy it over correctly, and you're going to make any notes about something that I might say. So I want to see active engagement on the right side. Don't just wait for me to do the problem and fill it in on the left. Okay, I want active engagement on that right, showing that you attempted the problem on your own. So go ahead, pause the video, and then we'll come back and do this one. All right, so for this, we have just 2 logs. Same base, these are natural logs, so the base is e, and I don't have anything else muddying that equation up, and so I can use this particular strategy. First step is to isolate one log on each side of the equal sign, so I'm going to begin this by adding the natural log of 4 to both sides. That is supposed to be a plus sign. So that's going to give me the natural log of x squared is equal to the natural log of 4. Once you have the logs equal, then you can set the arguments equal. So x squared is equal to 4. Now you can solve this by solving it like as a quadratic. So you could do this. All right, I'll make a little note. You could do this where you subtract 4 from both sides. Hopefully you recognize that as the difference of squares, and that the difference of squares factors into conjugates. Again, you cannot just keep forgetting that. If you're prone to forgetting it, it has to at some point get locked into long-term memory. And that factors x plus 2, x minus 2. And then you set each factor equal to 0, and here we'll subtract 2, and here we will add 2. So we have the two answers, -2 and 2, and then we quickly want to go back and check that over here. If I take -2 and I square it, I get a positive. If I get 2 and I square it, it's positive. Now, if that seems like a lot of work, that's because it kind of is a lot of work. And so most of the time in a situation like this, what we would do is we would just take the square root of both sides. You just have to remember that it's plus or minus 2 and not drop the -2. So a lot of times students will look at that and say, oh, x squared is 4, x is equal to 2, and they just don't think of the -2, which comes out of the factoring a little bit better. It'll also come out of the quadratic formula, which is way too much work. Okay, so what you should do if you got everything correct, maybe you might want to copy over in the spot on the right, like the alternate way. So if you did it this way, you would copy it over this way, just write alternate solution, or vice versa. If you got a +2, but you left out the -2, make that correction over here. It's okay to make mistakes when you're practicing. You just want to learn from those mistakes, make those corrections, and make sure that we have a learning process going on. All right, next strategy. If there is only one log, okay, so we're going to go over to a version of a problem where there's only one log, try changing it to an exponential. Okay, so try changing the form over. Now, to remember that, you have to remember this little fact. Okay, we did this several classes ago. That anything you have as a logarithm, you could write as an exponent. We were doing it in the other direction, where we were taking an exponent and changing it into a log, but of course we can go the other direction as well. So the base of my logarithm, which is right here, is going to become the base of my exponential. So it'll be b. And then this is where, I don't like using the lowercase e, but it comes in a little bit handy. The e is the exponent, and that'll be equal to whatever the argument is, which here is n. So that statement that I've written on the screen there should look very, very familiar to you, because we did it before when we were solving exponential equations, and we would take the exponent and change it over to a logarithm. Just now we're going in the other direction. Okay, so here's our first example. Log base 5 of x equals 3. Make sure you are saying that correctly. That's a question on your home test, and I've graded one of them so far, and we didn't quite get it right. So log base 5 of x equals 3. So to change that over to an exponential, the base of the logarithm is the base of the exponential, so it'll be 5. The number that is over here is the exponent, and then the argument is whatever's by itself. And so this becomes 5 to the 3rd power equals x, and hopefully that's one that's fairly easy to retrieve from memory. So 125. And again, double check your answer. Just make sure that it's not going to give you the log of something negative. So log of base 5 of 125. And this you could actually check on your calculator, because you know how to do that on your calculator. So punch in log base 5 of 125 into your calculator, and your calculator should tell you 3. And remember what the solution to an equation is. The solution to equation is always the values of the variable that make the equation true. So if you plug in 125 and you throw in your calculator, you get 3 equals 3, which is of course true. Example 2, we have a natural log there. So what might help you in this one is to rewrite it as log base e. So it might help you to do this problem just to remember what that ln stands for. It stands for natural log, and it's a log with a base of e. And then if you rewrite it, you can kind of make it fit the formula a little bit better, so it's visually a little bit easier. So in this case, the base is e, the exponent is 2, and that'll be equal to x minus 3. Now, in this case, some people might advocate for leaving it in exact form and not changing it like over to the approximate form. But for the purposes of this class, I am going to have you guys change it over to a decimal. So we're going to take e squared, and I am using my cell phone calculator because, oh, I have a calculator. It's like in front of me, but it's like my table's too far away. I can't reach it. So I got a laptop on my lap. I'm just not going to bother. So we're going to do, clear out whatever is already on there. E squared, and that is 7.389. We'll go out to 3 decimal places, and then isolate the x. So we'll add 3 to both sides. And just as with the exponentials, be careful about this. A lot of these are really easy to do in your head, but particularly if there is some subtracting going on, it's just so easy to make a little careless mistake by doing it in your head. So I would advocate just use your calculator. It's not worth making a silly mistake. If you are having a hard time reading that, that says 10.389 equals x. 10.389 equals x. Okay, so that's what you want. As before, pause the video if you need to finish writing something down before we move on to the next thing. Right, so as with the previous you try one, I do want you to pause the video, and I want you to try this on your own. Okay, without photo math, without anything else, just on your worksheet, try to do this. Try to solve it. I'll give you a verbal hint right now. The log, when you don't see a base written, the base is 10. So go ahead and pause the video, and then as before, when I go over it, you're going to make your corrections and make any notes over to the right. Okay, so as I mentioned, you need to remember for this is that when you don't see a base to a log, it's a log base 10. It's called a common log. And so when I try to rewrite this one, my base is going to be 10. My exponent is 1. And then my argument, which is now off by itself, is the 2x minus 4. And of course, 10 to the first power is just 10. And then that becomes a fairly simple linear equation. So we're going to add 4 to both sides. So we're going to have 14 equals 2x. Divide both sides by 2, and we get 7 is equal to x, or x is equal to 7. And before you, oh, I don't like how, now I'm going to erase that, but if you see like why I don't like how that box came out, because of the way the box is going around the other two, it makes it a little obscure. And I didn't see it like when I did the box, but like the answer is 7, and this 2 is the denominator of that fraction. It's the division there, but the way that it's boxed makes it look like 7 equals x squared. And so for clarity, I'm going to redraw that. And it's just, be mindful of stuff like that, that you're not accidentally making something look other than it is. Make sure that you are checking your answer. So 7, 2 times 7 is 14. 14 minus 4 is positive. Again, you're just checking to make sure that whatever you're taking the log of is positive. On your sheet, any mistakes that you made, anything that I might have said of interest, make a little note over here, make a correction, make sure that you're showing some active engagement with the notes there. Okay, now in the interest of efficiency, I am going to roll both classes. So the first video was first lesson was 25 minutes of my talk time plus however long you had to pause the video and at different points. So if you paused it for like 10 minutes, we might be talking about 45 minutes, okay? Which is totally reasonable for a lesson. We'll have 90 minutes in class to do it. So for class 2, I'm just gonna plow on through. So if you don't need class 2, you can exit the video at this point. Take the exit ramp if you'll be in class for class 2, and then hopefully if you are absent for class 2 only, you have fast forwarded to this point. So you fast forwarded to this point, so you don't have to watch all the stuff unless you want to. It's your call, it's my heart. All right, so second type is logarithmic equations, and this one is if there are more than 2 logs, or if the logs cannot be isolated. So you have 2 logs, but you can't get them isolated. Use the properties of logs to collapse them. And so this is going to stem right from what we just did in class with the properties of logs. So if you look at the 2 examples, both of those situations are outlined. So here you got 3 logs. Okay. And there's like different ways you could do this. Like we're not locked into a one way of doing this. You could actually collapse all of these. Not sure I recommend doing it that way, but you could do it that way. This one only has 2 logs, but see this 2 here, that falls into that, like make sure there's no other terms that complicate it. That 2 is going to mess it up. So I could move the log over to the other side, but it's still not going to be isolated because the 2 is over there. I can move the 2 out, but then the other log isn't isolated. So hopefully you can see what we mean there. So in this first one, we want to use the properties of logs to collapse them. So here I have 2 logs that are being added together, and the property I'm going to use is this one. I'm going to write at the top of your screen. If you have log of m plus n plus log of m, you can write that as a single log and multiply the n and the m. That is awful handwriting. It looks like a W, but it's so that's the property. So if you have 2 logs that are being added together, you can write them as a single log and multiply them. That is n times m. So in this problem, I could write it as log base 4 of x times 3, which is a little tiny bit uncomfortable. So let's write it as 3x, like so. And that's equal to 2. And now what I've done is I've used the properties of logs to write it like we had it in the last lesson, which is 1 logarithm. So now that I have it written as 1 logarithm, I can change the form over to an exponent. So in this case, the base is 4. The exponent will be 2, and that'll be equal to the 3x. So we're just going to go ahead and change the form. So 4 squared equals 3x. 4 squared is equal to 16. Divide both sides by 3, and quite frankly, I think I'm going to leave it like that. I think I'm just going to leave it like that. You could change it to, well, I wouldn't change it to a decimal because it's dividing by 3, so you'll have to round it. And then, as always, check that answer. This is a positive number. There's only one place for me to plug it in, and that's with the x, so it'll be the log of a positive, and it's not a problem. For those of you that are good at using your calculator, go ahead and evaluate this. So do like log base 4 of 16 over 3 plus log base 4 of 3, and then you should be able to verify that that is equal to 2. In the example on the left, I have, what do I have going on here? I have 3 natural logs, 2 of them being subtracted. I'm thinking of 3 different ways that I could do this problem. But I'll try to keep it, I'm going to try to keep this like as clear cut for you as possible. So natural log of x squared minus natural log of x equals a natural log of x plus 3. And I guess what we'll do is we'll collapse the 2 natural logs on the left. That is, I don't actually think that's going to be the friendliest way to do this, but it's probably the most obvious, like straightforward, like obvious for you guys. So so let's go ahead and do that. Now we'll go back up here. Okay, if you have two logs that are subtracted, then that collapses into division. So you take the argument of the first and divide it by the argument of the second. So that's what we'll do here. We'll do the natural log of the argument of the first divided by the argument of the second equals the natural log of x plus 3. Now, you might be looking at that and saying, well, x squared divided by x, I can use properties of exponents, and that's just equal to x. The problem with that is that's assuming x does not equal 0, which is actually a safe assumption because a 0 won't check when you go to plug it in. I feel like we're getting into some dodgy domain stuff. So for the time being, let's not cancel the x's out. And probably need to rewind what I just said because I just like a lot of information out there at once. Now that we've got it down to one log on each side, I can set the arguments equal. So I can say x squared over x is equal to x plus 3. Now, this is actually a type of equation that is often covered in Algebra 2 classes, but we did not cover it this year. A lot of the standard classes, it's one of those things we just don't get to covering. This is called a rational equation. If you think rational means ratio, and so you see on the left-hand side that we do have a ratio over there of x squared to x. And the problem here is that we've got a pesky denominator there that we don't really want. So if you think of the denominator, think for a moment like, okay, the fraction bar means division. I'll use my pointer here so you're not just listening to me. Fraction bar is division. I don't want the division. I don't want the fraction bar. So how do I undo division? I undo division with multiplication. And since I'm dividing by x, I'm going to multiply by x. So that will cancel the x's out. And then over here on the right, I'm going to distribute that x as I multiply through. And well, this is interesting. Look at that. X squared equals x squared plus 3x. Well, okay, math is consistent, so I think this is going to do something weird, but we're going to proceed because we know math is consistent and we know the rules don't change. So this is a quadratic. I know it's quadratic because of the x squared. To solve a quadratic, I can factor or use the quadratic formula, but in either case, I need to get a 0 on one side. So I'm going to go ahead and subtract the x squared from the left. And then this happens. X squared minus x squared is 0, and it turns out that the x squareds cancel on both the left and the right, leaving me with 0 equals 3x. So you can say, okay, well, that's 3 times x, so I'll divide both sides by 3. The other way you can think of that is 3 times something equals 0. What would that something have to be? What's the only thing that you can multiply 3 by to get 0? And you might arrive at the answer x is equal to 0. And that is not going to check. So remember, when we're checking our answers, we need to make sure that whatever we're taking the log of is positive. So if I come up here and I plug in 0 and I say natural log of 0, 0 is not positive, and the answer actually doesn't check. And so I'm going to cross it out. That means that this particular equation has no solution to it. Interesting. Now, in the interest of being interesting, another way, well, no, it would have just gotten us to the same place. I don't think I want to muddy the water with that. You could try to do this. Now I'm just having fun. You could do something like this, where you have x squared minus ln x, and then subtract the natural log of x plus 3, like try to get all the logs together. That'll leave you with a 0 on the left. That's an x. And then you could collapse all 3 of them, which would give you natural log of x squared over x times x plus 3. And then this would be e to the 0 equals that lovely thing. I'll go ahead and distribute that x. This is equal to 1 and we end up in, we end up in the same place. Okay. I think this first way was probably the most straightforward way. All right. Okay, I think I salvaged this. Oh my word. I accidentally clicked through this slide. I clicked like through it. And when you're recording these PowerPoints, there's no way for you to click backwards in the slide. Like I can click forward, but not backwards. So I have to like exit the recording and then I think it worked though. All right, so on the left, same template here. It's a you try one. So I want you to pause the video, try to do this on your own. Good, bad, ugly, do what you can do. Look back at your old examples, look back at the ones that I just did, flip back, do whatever you need to do. And then once you've given it the absolute best try you can, you're going to unpause the video and then use the space on the right-hand side for your corrections and notes. All right, so let's go pull this one apart. So this is one that's got 3 logs in it, and I don't have a formula or strategy for dealing with something with 3 logs. And so I have to collapse these somehow. So I'm going to take the 2 on the right and collapse them together. So those are adding. So when I collapse them into 1 log, I will end up multiplying. So this is going to be log of 2x equals log of 3 times x minus 2. And then once you have 2 logs and they're isolated, 1 on either side, then you can just set the arguments equal. So it just kicks back to the other strategy. And one of the things that you can see, I hope, about these lessons is you can see how the skills build. So in order to solve it like this way, you have to know the basic strategies that were taught in the previous lesson. In order to be able to collapse the logs, you have to know the properties of logs. And so this is one of the reasons why math can spiral out of control for students that miss a lot of class and who don't bother to make up the missing material as quickly as possible. I know sometimes life genuinely gets in the way of stuff, but it can just like snowball out of control. And if you haven't seen any of this, or just changing something from a log to an exponent and back and forth, like all of that stuff was covered in a previous lesson where that was the main skill. So, all right, solving this, we'll distribute the 3. I'll subtract 3x from both sides, getting negative x is equal to negative 6. And then I can fix that by dividing both sides by negative 1. You make sure that you are solving for positive x and not negative x. And then, of course, we do want to do that check. 2 times 6 is positive, and 6 minus 2 is also positive. And so that works. Over here on the right, pause and make any corrections. So a common mistake is for students to leave it with a negative x instead of an x. So if you need to make a little correction, make a little note to yourself about what to do there. If you forgot to distribute, I don't know, whatever you might have done. If nothing else, you can make a note about Miss Taylor went on a spiel about the importance of staying up to date with your homework so you don't get too far behind. And I believe that is class 2. So that I'm not able to click forward in the presentation. Okay, we'll figure it out. All right, I'm getting good at this. I'm getting good at figuring it out. It's also not going to let me click to slide 10 because apparently I completed the recording and now all I can do is edit it. All right, this is class 3, and the year that I'm recording this, I'm not entirely sure what, if anything, I'm going to do with the stuff at the end of the packet for class 3. One of my classes will get to class 3 A day, but B day won't. So we might try to do some of this at the end of B day. I don't know. I don't know, because that second lesson's really, really short. So I might have students just do this first problem. I don't know what we're going to do. But for the sake of making sure that the video covers everything that I might possibly decide to do in class, we're just going to barrel on through. So this is a T-chart. I actually did this last year when I had an observation of mine, and it says solve each of the following logarithmic equations and fill out the T-chart explaining what you did in each step. So instead of just copying work, and this kind of gets around using an app or copying off a neighbor, just to try to justify like what is happening in each of the steps. Like, what am I doing? Can I put it in words? Can I explain what's happening in each of these steps? So I thought we could do like at least one of these. So the first step that I got here, I got log base 3 of x squared equals log base 3 of 2x. And what did I do? I copied the problem. Like, that's what I did. I copied it over into my workspace. For the second step, I see that this is 2 logs with the same base, and I have 1 log on each side of the equal sign. And so I can write x squared equals 2x. And the way we describe that step, the way we put into words, like the process that we're doing there, is we set the arguments equal. So we have to have that vocabulary. Now I recognize that it is a quadratic, and a quadratic, you want to get a 0 on one side. So you could say like set equal to 0. You could say subtract 2x from both sides. I'm going to say set equal to 0. That's probably the mathier way of saying it. Now I'm going to factor. This is just GCF factoring. So that is factor out an x, and now we'll set each factor equal to 0. Okay, so set each factor equal to 0. That's also called like using your zero product property. And then right here I would add 2 to both sides. And so there are 2 answers, and we want to make sure that we check them. So if I plug in a 0, that will not work because 0 is not positive. Let's check the 2. 2 squared is positive. 2 times 2 is positive. So that one does check. So that's what is intended by the, like, what did I do, and what it, like, explaining your steps, explaining the process there, so that you're not just copying stuff or trying to navigate through a process, but that you can articulate what it is that you're doing in each step of that process. All right, and on this last slide, this should round out the problems in the packet. So if you're working through this at home, for the sheer joy of learning and the love of taking on a challenge, go ahead, pause the video, and see what you can do with this on your own. Just see what you can do with this. See if you know how good you are at solving the problem, and then coming up with an explanation, and then unpause it, and I'll go over it. I'll go over it to make sure that I'm rounding out this video with all of the possible content, and hopefully like explaining some stuff as we go. You might have noticed it's getting dark because it's after 8 o'clock. I don't know why I decided to do this now. All right, so we have, I'm not sure I can read that. I think it's log base 3 of 2x minus 3 equals 3. And again, that's copy the problem. Okay, copy the problem. Now this is a situation where there's 1 log. And so if there's just 1 logarithm, our go-to strategy is change it over to an exponential. So the base is 3, the exponent would be 3, and that would be equal to the argument, and so, which was 2x minus 3. And so what did I do there? I changed to an exponent. 3 to the 3rd power is 27. So I might just say 3 to the third power equals 27. I might actually just say that. Like it's basically evaluation and substitution. So you take 3 to the third, you evaluate it. That is equal to 27. And then the 27 you substitute for the 3 to the third power. Now I will add 3. Actually, you know what I'm going to do here is not show the adding 3. Okay, and I'll put that over here. So I added 3 to both sides, and then I'll let you guys think for a second. What did I do right there? I divided by 2. And so, and then we could check our answer. We always want to check the answer. So 2 times 15 is 30, minus 3 is positive. So there you go. And so again, that's, hopefully you have something that looks like that. Let's take a look at this last one because it's fun. So we have, what do we have going on here? We have some interesting stuff in this problem. This is a good problem. So we have log of 2x plus 1 plus 2 log 2 equals 2. That's a lot of 2's. So let's start by copying it over, which I don't have anywhere near enough room. So yeah, and that was copy the problem. Yep. All right, so I've got a couple of things going on here that we need to make a note of. I have 2 logs that are being added together, so I know I'm going to need to collapse those because that 2 is going to be problematic. But I have this other 2 right there that's in the way, and I can't collapse them as long as I have that 2 in the way. So I actually need to use the property of logs that moves the coefficient into the exponent. So I need to do that first. So I have to do this. Log of 2x plus 1 plus log of 2 squared equals 2. And for my reasoning, I think I'm just going to write this n log that is equal to log of m to the nth power. That was the property, so I'm going to state the property. Now I should be able to collapse them through multiplying. So I'm going to have log of, I'm going to use some brackets here just because I have a lot of stuff happening. 2x plus 1 times 2 squared, which of course is 4. And that was like the addition, I think it's called the addition property of logs. That you probably don't know. We're not going to sweat that right now. All right. So I don't even know what to do here. We got this. I'm going to say 2 squared is 4. Hopefully you guys are okay. I did 2 things right there. I did 2 squared was equal to 4, and I also moved its location over to the front. So it was like in a slightly better location. I didn't really like it over on the right-hand side. Now remember that this is base 10. So let's go ahead and change the form. So that'll be 10 squared equals. And while I'm writing it, let's go ahead and distribute. Okay, so that was change to exponent. And I also distributed. Distribute. That says distribute. 10 squared is equal to 100. So 10 squared equals 100. We're going to subtract 4. So minus 4 from both sides, and then divide both sides by 8. What is that? Is that like 12? And then I kind of ran out of space there. Right? 8 times 12 is 16. Yeah. And then we want to check that answer. So if I have x is equal to 12, 2 times 12 plus 1 is positive. Yay. So that worked. That last problem is a little bit of a doozy. So if you got tripped up on that, don't beat yourself up over it. That's that problem and threw a lot of stuff in there, but hopefully it was beneficial for you to go over it. And we made it through all 3 of those lessons in a 50-minute video, plus however much time you had to pause the video, hopefully not more than 40 or 45 minutes. So this is probably doable in a 90-minute class period give or take some, and it's not too overwhelming to do on your own. And for at least this school year, this is the last material that we are going to cover, and it's the last material that's necessary for you to complete your at-home test. So I hope that it was beneficial, and that you have a nice solid footing of exponentials and logs to go on to whatever class you move on to next.